Hello everyone, welcome to Algebra 1B. We are working our way on week 6 with factoring polynomials. So make sure you're going through all the sections in our online CK12 textbook. There's lots of great stuff in here. Again, we don't cover everything exhaustively in this video. Try to keep it short, about 20 to 30 minutes, but there's a whole lot more for you to read and watch in there as well. Take notes, do practice problems, put in the time this week, and let me know if you need any help working on your assignments for the week as well. Your objectives, what we're going to work on this week for week 6. If I give you a polynomial, can you recognize and factor a common monomial out? If I give you a polynomial equation, can you factor it and use the zero product property to find the solutions? I'm going to give you a trinomial with a leading coefficient of 1, and I want you to recognize factoring patterns and rewrite it as two binomials multiplied together. And then finally, there's a special binomial that I want you to recognize if it's a difference of two squares and factor appropriately. Lots of stuff with polynomials and lots of stuff with factoring. This is what we got going on this week. I want you to be able to do all these things efficiently. So last week, what did we do? We started looking at what a polynomial is, and we learned how to add, we learned how to subtract, and we learned how to multiply them, right? What about division? How do we divide polynomials? Well, some division we get into later, but instead of division for our class, we focus more on methods of factoring. What do I mean by factor? Well, let's start with just the number 12 here. How would I factor the number of 12? Well, you may think of like a factoring tree, right? 12 is the same as 3 times 4, but then 4 I can split up into 2 times 2. And so it factors 12 factors into 3 times 2 times 2. So when we're factoring, we're looking for what are smaller things that multiply into the larger item. We're going to do the same sort of thing with polynomials. We're going to take one big polynomial and over this week and next week learn how to break it down into smaller polynomials multiplied together. That's factoring. So let's start off first by factoring out some monomials. If you remember, a monomial is just a way of saying a one-term polynomial. So it can have numbers, it can have variables, but just one term. So let's look at, we got 24 times a to the 5th times b to the 3rd. And we have this other monomial right here, 16 times a squared times b to the 10th. What is the largest common factor of both monomials above? So I'm looking for factors, so things that multiply. I'm looking for what's in common, so both this term and this term have the factors. I'm looking for the largest. What is the most that they have? Well, let's start with just the numbers. So 24 and 16, let's list out all the factors. 24 has the factors of 1, 2, 3, 4, 6, 8, 12, and 24. Those are all numbers that divide evenly into 24, and they're all factors. 2 times 24, 3 times 8, 4 times 6, and so forth. For 16, that has factors 1, 2, 4, 8, and 16. So if we're looking for the largest common factor, I'm going to look at all the factors, and the largest one they both share is 8. So the largest common factor then is going to be 8. But it's algebra, right? I got some variables to deal with as well too. So how do I find common variables? Well, let's start with a to the 5th. So I've got a to the 5th in one, and I've got a squared in the other. Well, remember, our exponents just mean how many we have multiplied, right? So a squared just means a times a, and a to the 5th means a times a 5 times. Well, again, I'm looking for the largest amount they have in common. So there's 2 and 2 over there that they both share. They both have 2 factors of a in common with each other. So I can rewrite that as a squared. They both have 2 factors of a in common. Same thing with the b's. There's 3 b's here, b to the third, but 10 b's here, but in common, they both have a factor of b and they both have 3 factors of b. So I would put down b to the third. This would be our greatest common factor. Eight times a squared times b to the third factors evenly into that monomial, and it factors evenly into that monomial. Okay, let's take another look at a greatest common factor. So we've got a binomial, 10 times a to the third minus 6 times a times b. There's 2 terms, binomial, and I want to factor out what I can. Well, let's look at what they have in common here. So for this first term, 10 and 6 both have a factor of 2 in common. I can divide those evenly by 2. I can divide 10 by 5, but 5 does not go evenly into 6, so 5 is not a common factor of the numbers. When I look at the variables, I have a on the left and a on the right. I have a to the third, so 3 factors of a times a times a on the left first term. But on the second term, I only have a to the first. If there's no exponent, that just means there's only one a. So in common, they both share a factor of a. There's a factor of b in this term, but there is no factor of b in the first term, so they don't have that in common. So if I wanted to rewrite it, I'm going to factor the following binomial. These are common factors of 2a. So I'm going to do the opposite of the distributive property. I'm going to divide out the 2a and put it in front, saying, okay, both of these used to be multiplied by 2a, but I divided it out and put it off to the side. But what do I have left after I divide out that 2a? Well, 10 divided by 2 is 5. A to the third divided by 1a is going to leave a squared left, minus 6 divided by 2 is 3. A to the first divided by a to the first, those divide out to be 1, so I don't have any more a's, and then I just have the factor of b left. So there we go. If I want to factor the binomial, we just factored out the greatest common factor, put it in front with parentheses, and divided to see what was left in the parentheses. If I want to check my work, just check by using the distributive property. Take 2a, multiply it back in, and see if it gets you right back to what you started with. But there you go. That is factoring the binomial. And if you're going to start with factoring, the first thing you want to do is factor, like we did here, see if there's any greatest common factors. The greatest common factor. And you always want to factor that out. That's not so bad, right? Just going the opposite of multiplying the distributive property is dividing it and factoring it back out. Okay, so now before we really dive into too much more factoring, let's just look a little bit about how we can use it to help solve equations. So overall, factoring, again, when we're dealing with polynomials, we're dealing with learning new algebra skills, adding, subtracting, multiplying, dividing, so that we can tackle more complicated types of equations and functions in the future. We're leading towards what are called actual quadratic functions, but we can't do that until we're really comfortable with polynomials, adding, subtracting, multiplying, and factoring. Okay, so let's look at how do we actually solve polynomial equations. How does factoring help us solve them? Again, here's an equation. I've got x plus 3, a binomial, times x minus 9, and I want to know, well, what value of x is going to turn that into 0? Well, one thing, if we think back to all of our multiplication skills, anything multiplied by 0 just is 0. Anything multiplied, I'll write that out here, by 0 equals 0. For example, I could have 42.95. It's a great number, but if I multiply it by 0, what does that equal? It just equals 0. We use that idea and we think a little bit bigger, a little more abstract. We use it with polynomials. I've got two things multiplied, and I know when it equals 0. Things only multiply to equal 0 if one of them is 0. So to solve this, I want to know, when does x plus 3, when does that first factor equal 0? And I want to know, when does x minus 9 equals 0? If either of those equals 0, then the whole thing equals 0. Well, some number plus 3 equals 0. That's easy. Let's subtract 3 from both sides, and I can see one solution is negative 3. So if I make x negative 3, I get 0 times negative 12, which is 0. That's a solution. I like that. The other one is, if I add 9 to both sides, is if x equals 9. Check it out. If I put 9 in for both x's, I get 12 times 0. 12 times 0 is also 0. So there's two solutions in this case. That's a little bit different, right? Different than linear. But this is where we're heading towards, and this is one of the uses of factoring, is as I get more complicated polynomials or complicated algebraic expressions, if I can get it equal to 0 and factor, I'm able to solve these, whereas before I couldn't. So let's take a look at another one here. I've got 3 times b squared, and I want to know, when does that equal 9 times b? What value for b is going to make both sides equal to each other? Well, I'm going to use factoring as a method to solve it. I can't use all my stuff that I did before with linear stuff because I have a b squared and a b. So here we go. We're going to use factoring. The first step is, let's make it equal to 0. It only works if I have it equal to 0, because then I can use my zero product property and all that stuff we just did. So to get it equal to 0, I'm going to subtract 9b from both sides of the equation. And now we've got 3 times b squared minus 9 times b equals 0. Got to get it equal to 0, because then I can factor it and get my factors of 0. So check number 1, we did it. Now, let's actually factor. So I'm going to look for common factors here. In between my two terms, they both have a factor of 3. They can divide by 3. And they both have one factor of b. So I'm going to divide a b out. What am I left with? Well, if I divide out my common factors of 3b, 3 divided by 3 is 1. B squared divided by 1b leaves just 1b. Minus 9 divided by 3 is 3. B divided by b just leaves nothing. It's 1. So using the opposite of the distributive property, it factors into this. 3b times b minus 3 in parentheses, and it still equals 0. All right, that is all factored. Check. Finally, now I can actually solve it. Let's solve for when each factor on the left equals 0. So there's two factors. There's a 1. When does 3b equal 0? And there's another factor right there. When does b minus 3 equal 0? Well, the only way on the first one, if I solve it, is if b equals 0. And the other one, if I add 3 to both sides, looks like when b equals 3. So there's two solutions. If b equals 0, if I put 0 in here, I get 0 equals 0, that's equal. If I put 3 in there, I get 3 times 9, and I get 9 times 3, so that's equal. So my solutions to that equation are b equals 0 and b equals 3. Check. There we go. That's using the zero product property. That's using factoring. And we're able to start solving equations that we couldn't solve before. We couldn't figure out what b was. All right, so factoring. There's lots of different polynomials. We're going to start to look at different methods this week and different methods next week on how to recognize, how do I factor, what steps do I need to do, am I using the right method? And we're going to do some reviewing on multiplying as we do it as well too. So let's start with these two examples. Let's multiply them out. Again, these are already factored form. So these are already factored. But let's multiply them out and see what we get. So again, distributive property, every term needs to multiply every other term. So let's start with the x times x gives me x squared. Then I have the x times the 5 gives me plus 5x. Then the 3. 3 times x gives me 3x. And finally, 3 times 5 gives me 15. Okay, I can simplify my two middle terms, and they equal x squared plus 8x plus 15. All right, let's do the other one down below. Let me switch pens. Start with x. X times x gives me x squared. X times 9 gives me 9x. Then I hit the 2. 2 times x gives me plus 2x. And finally, 2 times 9 gives me 18. So if I simplify my two middle terms, 9x plus 2x gives me 11x. Okay. Well, now factoring is going in reverse. So let's see if we see any patterns between, if we start with this, we look at the numbers here, we want to develop a plan for how do I factor it back into that. Well, here I've got the numbers 15 and 8. I got the 15 from the 3 times 5, and I got the 8 from the 3 plus 5. On this one, we've got 18. Now let's compare with what we started. 18 came from the 2 times 9, but the 11 came from the 2 plus 9. 9x plus 2x right there. The same on the 8 and the 8x. 5x plus 3x right there. So it looks like whatever my factored form is really related to the numbers that I originally had. In fact, that leads us into how we factor these types of trinomials. If I have a trinomial, that's 3 terms, then the leading coefficient is 1, which means that x squared, there's no numbers in front of it, just the 1x squared. Then those are pretty straightforward to factor. What I need to do is find two numbers that add up to whatever my middle term b is, but yet multiply. The same two numbers need to multiply to equal c. If I can find those two numbers, boom, I'm factored. So let's do a couple examples here. We got x squared plus 7x plus 6. That's a trinomial. I want to factor it back into two binomials. According to this, let's look at what our value for b is. B is the middle term. So in this case, b is 7. And c is the final constant term. So in this case, c is 6. Can I find two numbers that when I multiply them, they equal 6, but when I add them, they equal 7? Well, 6 times 1 equals 6, but 6 plus 1 equals 7. There's my two numbers, 6 and 1. So I can factor it then into x plus 6 times x plus 1. These are the two binomials that multiplied to make this trinomial. And if you want to, which I highly encourage, you should check by multiplying. So check by multiplying it all out. Let's actually see if it works. Does x plus 6 times x plus 1 really get me back to what I started? Well, x times x gives me x squared. X times 1 gives me 1x. 6 times x gives me plus 6x. And 6 times 1 gives me 6. And I can see, yeah, 1x plus 6x gives me the 7x. So it's good. It checks out. Let's do one more over here. So on this problem, we've got b is 11. I need two numbers that add up to 11, but multiply to make 24. And hopefully it's easy to see that those numbers are 8 times 3 and 8 plus 3. So this factors into x plus 8 times x plus 3. I'll let you check this one, but you can see 8 times 3 is going to give me the 24 when I multiply it out. And then when I have 3x plus 8x, when I multiply all my terms, that's going to give me the 11x. So there is my factored form of that one. So again, rewriting things, working our way backwards. Last week we took two binomials and multiplied them to get a trinomial. We're just going in reverse. Now we have the trinomial and we want to work our way backwards to figure out two binomial factors that multiplied into it. What if we have some negatives? The same thing works. We just have to be careful of what our negative numbers are in negative multiplication. Let's do this one over here. X squared minus 4x minus 32. So b, our middle term, is negative 4. It's the coefficient there. Our value for c is negative 32. So I need two numbers that add up to negative 4 but multiply to negative 32. Negatives can be a little bit trickier, especially in terms of the adding part. But so sometimes what helps is I'll start listing off all the ways to get negative 32. So 32, that's 1 times 32, 2 times 16, or let's see, 4 times 8, and that's all of them. Now out of those, it's negative 32, so one of these numbers has to be positive, one of them has to be negative. Now they add to negative 4, so I'm looking for the only ones that seem to have a difference of 4 would be 4 and 8. So to get negative 4, I need to have the 8 be negative. Negative 8 plus 4 is going to give me negative 4, and then negative 8 times 4 is going to give me negative 32. So there we go. We have it factored out now. It's x minus 8 times x plus 4. And how do we check it out? We multiply it back together and check to make sure we get right back with what we started. You can see why multiplying is really helpful so that you can factor better. If you're not very good at multiplying, you have a rough time trying to factor and keep everything straight. Let's do one more example over here. A, B, and C. So B in this problem is 5. It's a leading coefficient of 1, so I can use just B and C. B is negative 66. And now I've got to find my two factors, right? Two numbers that multiply to negative 66 but add to positive 5. Let's start listing out 66s. So it's 1 times 66, 2 times 33, 3 times 22, 4 does not go in, 5 does not go in, 6 and 11, 6 times 11, and that's all of them. Okay, there's my 66. It's negative, so I know one number has to be negative, one number has to be positive. But the difference, they have to be able to add up to 5. And the only combination that has a difference of 5 is this one, 6 times 11. It's positive 5, which means the 11 has to be greater than the 6, which is negative 6. So there we go. So we have negative 6 times 11 gives me negative 66, but negative 6 plus 11 gives me positive 5, and it factors into this right here. All right, there's factoring trinomials. Went through a lot of examples. Again, use B, use C, find your two factors, and then you're good, and then you can always check by multiplying them out. We got some special cases I want to get into. Let's review a little bit more multiplying. Do you remember what happened when we multiplied and had the same numbers, but one was positive, one was negative? Well, let's just check it out. A times A is going to be A squared minus 5A plus 5A minus 25. And that's going to equal, again, my middle terms turn into 0, so it really just equals A squared minus 25. So we end up getting a nice binomial. Let's look at another one. 2y times 2y equals 4y squared. 2y times 9 is going to be plus 18y. Minus 9 times 2y is going to be minus 18y. And finally, negative 9 times positive 9 is going to be negative 81. Well, again, I got plus 18y minus 18y, so it just turns into 4y squared minus 81. There's only two terms left. So this was a special case of the difference of sum and difference formula, right? Same numbers, 2y, 2y, 9, 9. The only difference is one is positive, one is negative. When they multiply, your middle terms always turn into 0, right? But now again, we're trying to work our way backwards. I want to undo it. So what happens if we start with this? If I have a squared minus 25, can we recognize what is going on and get it back into this? Well, anytime you see two terms and both terms are something squared, a squared, 5 squared, there's 2 squared, y squared, 9 squared. If you have a difference of two squares, if you're subtracting two squares, it will always factor into two binomials with the squares, but one is positive, one is negative. All right, so let's summarize that up. If you can tell that you have a squared minus b squared, if you can see that in a binomial, if you have that pattern going on, it will always factor it into a plus b times a minus b. Here's a couple examples. 16 is 4 squared. There's a squared. And that's minus 9, which is 3 squared. So I have a lot of squareds going on. That's the difference of two squares. That fits that pattern. So it's going to factor into 4a minus 3 times 4a plus 3. I just take the square roots, the 4, the a, and the 3, and ignore the squares and just write that in my term. One is negative, one is positive. Let's look at one more down here. Like, this is my favorite one because if you can recognize what's going on, it's really easy. 25, that's 5 squared. X squared is x squared. 64 is 8 squared. And y, there's my y squared. I've got a difference of two squares is being subtracted. It fits that pattern of something squared minus something squared. So it factors into 5x minus 8y times 5x plus 8y. There you go. That's a special case, a difference of two squares. And it's one of those nice things to keep in your pocket and to look for as you're factoring a wide variety of polynomials. Okay, we are done. In our live class, we're going to be playing Kahoot. But again, if you're watching this video, we're just going to blow right by this and wrap things up. So, what did we all do today? If I gave you a polynomial, we factored out common factors. We learned how to solve polynomial equations using the zero product property to find the solutions. We did trinomials with a leading coefficient of 1 and looking at what b was and c was and being able to factor them. And we did a special case of binomials where you have the difference of two squares and you're factored out. All right, good work. I look forward to working with you guys, and let me know if you need help on any of the assignments, and have a great week.